Hey everyone, welcome to another Linkvideo's Deep Dive. You know how much you've all been wanting to explore new advancements in LM technology. So today we're going to do exactly that.
Sounds good.
Specifically, we're going to dive into a new approach to retrieval augmented generation. Right, and this one's called PathRAG. It's like we're giving LLMs a serious upgrade to their research skills.
I like it.
Our guide for this journey is a research paper. It's called PathRAG: Pruning, Graph-Based Retrieval Augmented Generation with Relational Paths.
Okay, so what's really fascinating about PathRAG is that it helps LM understand relationships between different pieces of information.
Oh, so not just the information itself, but how it all connects.
That's exactly like not just isolated facts.
That makes sense because, in real-world research, it's rarely about individual facts in isolation, right? It's about the bigger picture.
Yeah, and traditional RAG methods, they often fall short when you have these complex questions that require connecting the dots between, multiple sources. It's like having a massive library, but with no librarian to guide you.
You might find books with relevant facts, but you wouldn't know how they all fit together.
Okay, so how do you get around this flat structure problem? Right.
Is that where graph-based R comes in?
Precisely. So imagine if you took all the information in that library and organized it like as a giant interconnected web of concepts.
Okay.
That's essentially what a graph database does. Each entity, it becomes like a node in this graph, right?
And then the relationships between them form the edges.
This allows LM to navigate the information much more intelligently.
Okay, so instead of retrieving like a jumble of facts, graph-based RAG is helping the LLM find these insightful connections that lead to a deeper, more comprehensive understanding. It's like those moments when you're researching something and suddenly different pieces of information click into place.
Yeah, exactly, and you see the bigger picture. For instance, imagine you're trying to understand the factors that contributed to a historical event. A graph-based RAG system could help you map out all the actions, the motivations, and the interactions of all the key players.
That's cool. Okay, I'm starting to see how this could be a gimmicker, right?
But you mentioned that there have already been attempts at graph-based RAG. What makes PathRAG stand out from the crowd? So, previous methods like GraphRAG and LightRAG, they had a tendency to retrieve too much information, even irrelevant details.
Okay, so it's like information overload.
Think of it as information overload.
Right. It's not just about finding more information. It's about finding the right information.
And understanding how it all connects.
Exactly.
So how does PathRAG address this? So PathRAG takes a very clever approach, okay? Instead of simply retrieving everything that's connected to a set of nodes, it focuses on finding the most important relational path between them. It's like having a super-efficient librarian who not only knows where all the books are, but also understands the subtle connections between them.
Okay. Can you break down this relational path concept a bit further for me? What are we talking about here?
So think of it as a chain of connections that reveals a meaningful relationship between two entities. For example, in our historical event scenario, a path might represent the sequence of actions and reactions that led to a particular outcome.
So PathRAG is like a detective, meticulously tracing these crucial chains of evidence, these relational paths.
That hold the key to answering complex questions.
Exactly. And it does this through a three-stage process.
3 stages.
Yeah. The first is called node retrieval. PathRAG identifies the keywords in your query and uses them to locate relevant entities in the graph database.
It's like starting with a list of potential suspects, our detective analogy.
Okay, narrowing down the field. So what happens next?
The second stage is called path retrieval.
Path retrieval.
Yes, and this is where PathRAG uses a special algorithm to find the most important paths between the retrieved nodes, filtering out the noise and focusing on the most reliable connections.
So it's like our detective is sifting through the evidence, right? And identifying the most promising lens. This flow-based pruning algorithm sounds pretty sophisticated.
It is. Can you give me a sense of how it works? So it's based on the idea that the closer two nodes are in the graph, the stronger their connection is likely to be. The algorithm simulates the flow of information through the graph and assigns a reliability score to each path based on how well the information flows through it.
Okay.
Paths with higher scores are considered more reliable.
So it's kind of like finding the most direct and logical route between 2 points. But instead of a physical map, it's a map of interconnected concepts.
Exactly, and this reliability score is key because it influences how the information is presented to the LM in the next stage. Precisely, and that final stage is answer generation.
Answer generation.
Remember that LLMs can have like a lost in the middle issue?
Right. Like when you're trying to remember a long list and the items in the middle tend to get fuzzy.
Exactly. To avoid this, PathRAG strategically organizes the information from the retrieved paths in the prompt that's given to the LM.
Okay.
It places the most reliable information at the beginning and the end.
So like the bookends.
Yes, the golden memory region for LM, yeah, ensuring that those crucial connections are easily accessible.
So it's like giving the LLM a cheat sheet highlighting the most important information so it doesn't get lost in the details.
You got it. And this careful prompt design, it leads to answers that are more logical, coherent, and comprehensive because the LM has a clear roadmap of the most important relationships.
This is all incredibly fascinating. But I have to ask, did this clever path-finding strategy actually lead to better performance? Did PathRAG deliver on its promise?
The research paper shows that PathRAG consistently outperformed both traditional and other graph-based UARGI approaches across a variety of data sets and evaluation metrics.
Okay, I'm all ears. Tell me more about those data sets and how they measured the performance.
Okay, so they used 6 data sets covering topics like agriculture, law, history, computer science, and even like a mix of literary classics. And to evaluate the quality of the answers, they focused on 5 key dimensions. Comprehensiveness, diversity, logicality, relevance, and coherence.
Those sound like pretty solid indicators of how well an LM can tackle complex questions. So, how did PathRAG fare on these metrics?
Here's where it gets really interesting. PathRAG consistently outperformed the other methods, especially when it came to larger data sets. This suggests that PathRAG is particularly well suited for those real-world applications where we're dealing with massive amounts of information.
Okay, yeah, that makes sense. The more information there is, the more important those connections become. And that aligns perfectly with my interest, given the kind of data-heavy projects I'm always working on. So, how much better did PathRAG perform? Are we talking about a small improvement, or like a significant leap forward?
The results were pretty convincing. For instance, on the legal data set, which had a substantial amount of complex information, PathRAG achieved a win rate of over 60% compared to the next best method, which was LightRAG.
Over 60%. That's a remarkable improvement, especially given the complexity of legal texts. But what about those 5 evaluation dimensions you mentioned earlier? Comprehensiveness, diversity, logicality, relevance, and coherence. Did PathRAG excel across all of them?
Yes, it did. It showed significant improvements in comprehensiveness, meaning its answers were more detailed and thorough. It also scored higher in diversity, indicating that it was able to consider different perspectives. and provide more nuanced responses.
That's really impressive. What about the other three dimensions? Logicality, relevance, and coherence. I imagine those are crucial for ensuring that the answers are not only comprehensive and diverse, but they also make sense and are actually useful.
Absolutely. And PathRAG delivered on those fronts as well. Its answers were judged to be more logical, meaning they followed a clear line of reasoning, are also more relevant to the questions asked, and maintained a strong sense of coherence. So the information flowed smoothly and was easy to follow.
You know, I'm starting to see a pattern here. It seems like PathRAG's strength lies not only in finding the right information, but also in presenting it in a way that makes sense, allowing the LLM to grasp those complex relationships and provide more insightful answers.
You've hit the nail on the head. Okay.
It's not just about having access to information, right? It's about understanding how it all fits together, right?
And PathRAG's ability to do this has some interesting implications for the efficiency of LLMs. Okay, now you've really got my attention.
Okay. Tell me more about how PathRAG impacts efficiency.
So, one of the challenges with LMs is that they can be quite computationally expensive to run.
Right? Especially when processing large amounts of text.
Yeah, sure. But PathRAG actually helps to address this issue because it's so effective at zeroing in on the most crucial information. So by filtering out the noise and focusing on those key relational paths, PathRAG essentially streamlines the information processing for the LM.
Exactly. And this streamlining translates into something called token efficiency.
Token efficiency. Essentially, tokens are the fundamental units of text that LMs process.
I see. So the fewer tokens an LM has to process, the more efficient it becomes.
Precisely. And because PathRAG is so good at pinpointing the most relevant information, it can achieve the same level of performance as other methods while using significantly fewer tokens.
That's great.
This translates to lower computational costs and faster processing times.
So, it's not only making LMs smarter, it's also making them leaner and more efficient.
Just a win-win.
It's a win-win, especially for someone like me who's always looking for ways to optimize my workflows.
Indeed. However, it's important to remember that no research is perfect.
Right?
The authors of the PathRAG paper were very transparent about some of the limitations of their work.
Okay, let's talk about those limitations, right? What areas did they identify for future improvement?
So one limitation they mention is that the evaluation of PathRAG, like many other graph-based RAG approaches, relies on LM-based metrics, rather than human annotated datasets.
So it's basically LM judging other LMs.
Yeah, it's not ideal.
That sounds a bit like marking your own homework.
It's not ideal, but it's often necessary in this field due to the complexity of evaluating LM-generated texts. Right? However, the authors acknowledge that having human annotated data sets would provide a more robust and reliable evaluation.
That makes sense. What other limitations did they point out?
They also mentioned that the path retrieval algorithm, while effective, is still relatively simple and could be further enhanced.
So, there's room for even more cleverness in that crucial path-finding stage.
Absolutely. The author suggested that incorporating more sophisticated techniques like deep learning models could potentially boost the algorithm's ability to pinpoint the most relevant and reliable path.
This feels like the beginning of a very exciting journey. PathRAG is clearly pushing the boundaries of what LLMs can do, and it's opening up a whole new world of possibilities for understanding and reasoning about complex relationships.
Precisely. And one of the most intriguing questions this research raises is what other types of relational structures beyond path could we explore to further improve retrieval augmented generation?
Oh, that's a fantastic question. We've been focusing on paths, but I imagine there are other ways to represent and leverage those connections between pieces of information. It's like opening up a whole new dimension of possibilities.
Exactly. Think about hierarchies, clusters, or even more abstract networks of relationships. There's a whole universe of possibilities waiting to be explored.
It's incredible to think about how a single research paper like this can spark so many new ideas and potential avenues for innovation.
It really highlights the rapid pace of progress we're seeing in the field LLM.
Absolutely. It seems like every week there's a new breakthrough that expands our understanding of what LLMs can achieve. And thanks to this deep dive into PathRAG, we're now a little bit closer to understanding how those breakthroughs happen. It's been a fascinating journey, and I bet you're already thinking about how you can apply these insights to your own work with LLMs.
I certainly am. It's always rewarding to explore these complex topics and make them accessible to a wider audience.
Well, you've definitely succeeded in doing that today. PathRAG is a complex topic, but you've explained it in a way that's clear, engaging, and relevant to our listeners' interests.
Thank you. It's been a pleasure.
So to wrap things up, let's recap the key takeaways for our listener. PathRAG is an innovative approach to retrieval augmented generation that leverages graph structures to help LLMs understand the relationships between pieces of information, not just isolated facts. This leads to more comprehensive, coherent, and logical answers, especially when dealing with large data sets.
And importantly, it does all of this with greater efficiency, which is a huge plus for anyone working with LLMs.
And perhaps even more exciting, PathRAG is just the tip of the iceberg. It opens up a whole new world of possibilities for exploring different ways to represent and leverage those crucial connections between pieces of information. It's like a call to action for researchers and developers to keep pushing the boundaries of what's possible with LLMs. Well, on that note, I want to thank you for joining us on this deep dive into the world of PathRAG. I hope you found it as insightful and thought-provoking as I did.
It's been a pleasure sharing these insights with you. And to our listener, thanks for being part of this journey with us. Please like and subscribe to our channel. We encourage you to check out the full research paper, which we've linked in the show notes. And if this deep dive has sparked your curiosity, we highly recommend exploring some of the other amazing research happening in this field. We've included links to a few related papers in the show notes as well. Until next time, Linkvidi's fans, keep exploring, keep learning, and keep diving deep.